Hey all, in this video we're going to focus on two things: writing equations in slope-intercept form and interpreting and graphing equations in slope-intercept form. So really, we're focusing on slope-intercept form. So first, let's get a little bit of vocab. So a linear function is a function when graphed makes a line. So remember, a line has to be straight and a line continues on in both directions for forever. The slope of a line is how steep it is. The bigger the number, the bigger the slope, the steeper it is. The converse is also true. So the smaller the number, the less steep it is. The y-intercept, where a graph intersects the y-axis. So remember, this is our x, this is our y. So this would be my y-intercept. Now, it's also important to know that the y-intercept is where x is always 0. Right? So if we think about our number line on our x-axis, this would be 1, this would be -1. So x is always 0 along the y-axis. The x-intercept is where a graph intersects the x-axis. So down here, this would be my x-intercept. And now instead of x being 0 for the y-intercept, 0 is where y equals 0 is now our x-intercept. And then slope-intercept form, this is what we're most familiar with, is y equals mx plus b, where m is our slope, not mx, just m, and then b is our y-intercept. All right, so we're just going to practice really quickly finding the slope given 2 points. So we're not doing the equation of the line yet, we're just finding the slope. So remember that slope is rise over run. And rise is our y's, runs are our x's, right? Rise goes up and down, so that's our y-axis. Runs go left and right, so that would be our x-axis. So slope, rise over run, is the change in your y's over change in x. And then the formula that we use is y sub 2 minus y sub 1, because that would be the changes in your y's or your rise, over the change in your x's, so x sub 2 minus x sub 1. So this is the slope equation that we rely heavily on, and you should have seen before at some other point in your mathematical career. Now, you'll notice in number 1, I'm given 2 points, -3,7 and -2,4. I like to personally label my points, so I pick my first point, and that's going to be my x sub 1, y sub 1, and my x sub 2, y sub 2. So from there, it's just substitution. So I put my y sub 2 in for y sub 2, my y sub 1 in for y sub 1, my x sub 2 in for x sub 2, and my x sub 1 in for x sub 1. And then notice y sub 2 is over x sub 2, and y sub 1 is over x sub 1. So I'm going to have 4 minus 7 over -2 minus -3. And then we just simplify. So 4 minus 7 gives us -3 in the numerator. And then in the denominator, the minus and negative becomes plus. So -2 plus 3 is 1. And then we simplify as much as we can. So -3 divided by 1 is -3. So if you get a fraction off for your slope, just make sure you are simplifying completely. Let's just do one more where I lead you. So number 2, same thing. I label it x sub 1, y sub 1 for my first point, x sub 2, y sub 2 for my second point. Substitute into my equation. So I'm going to have my slope is -2 minus 0 over -3 minus -3. Simplify the numerator. -2 minus 0 is -2. And then negative 3 minus negative 3 becomes negative 3 plus 3, or 0. Whenever 0 is in the denominator, we can't do it. So our slope here is actually undefined. So just kind of a quick little note I would like to make off here to the side. Kind of as a follow-up to that, you can't divide by 0. Whenever this happens, your slope will be undefined. But, this is a big but, you can do 0 divided by anything. Whenever you have 0 on top, your answer is just going to be 0. Meaning you'd have a 0 slope versus an undefined slope. So 0 on the bottom is undefined, 0 on top is a 0 slope. All right, so let's just kind of review what slope looks like graphically. When we have a positive slope, your line is increasing from left to right. Right? When it's positive, it's going up as you read the graph from left to right. When it's negative, it's going down from left to right. A 0 slope means there is no rise and it's all run, because no rise, all run, so 0 over something is just going to be a horizontal line. And then undefined slope, we saw that in our last example when we had a number on top and 0 on bottom, meaning it's all rise, no run. That means that line is just going to go up and down for a vertical line. Now, that can be a little difficult to remember, so I have a little trick to help you out. Hoi, vux. So for hoi, the H stands for horizontal. The O means you have a 0 slope. And then Y, because it's Y equals some number, is always that equation for that line. So that will give you a horizontal line every time. So for example, if I pass through and have a y-intercept of 2, this equation would be y equals 2, and it has 0 slope. Vux, the V means it's a vertical line. The U means an undefined slope. And then it's going to be x equals some number. So if you think about what that looks like graphically, you'll have a vertical line. It will have undefined slope, and it will pass through some value on your x-axis, so have an x-intercept. We'll say a 3. Meaning the equation of this line would be x equals 3. So the value at every point here, every x is the same, every x is 3. Perfect. So hoi, horizontal, 0 slope, y equals a number. Vux, vertical line, undefined slope, x equals a number. All right, so let's get into some examples here where we write the linear equation in slope-intercept form. So y equals mx plus b. So you'll notice you are given your m already. And remember, y-intercept is where x is 0. So notice how your x-coordinate here is 0. That means that your b, or your y-intercept, is at -3. So we just substitute those values in to have y equals 1/5 x plus -3, but that's clunky, so we just write y equals 1/5 x minus 3. And then I just want to review quickly with you some graphing. So you plot your y-intercept first. So I'm going to go ahead and plot my y-intercept first. That's your first step. And then you deal with your slope of 1 over 5. So you're going to rise 1 from your y-intercept, run 5. Rise 1, run 5. And conversely, you can go your y-intercept and go down 1, left 5. And then down 1, left 5. Now, you just kind of want to double check before you connect your points. You have a positive slope, so it should be increasing left to right. So you would take a straight edge and you would connect all of your points. And your graph should look something like that. Now let's go the other way. I give you a graph. Let's write the equation. So your first step, like with graphing, is you identify your y-intercept. So find where it crosses the y-axis. So here, my y-intercept is -5. And then identify your slope by going up and over until you hit your line. Now it's helpful to find a point that's nice and defined on the lattice. So notice how it's a nice defined points where it crisscrosses. So I count up 1, 2, 3, 4, and I'm going up, so that's +4. And then I go left 1, 2, so that'd be -2. Meaning my slope would be 4 divided by -2 or -2. You'll notice there was another point here that I could have gone to as well. So when I go to slope-intercept form, I'm going to have y equals m. My m was -2. X plus b, so -5. All right, perfect. Take a moment and see if you can figure out the equation for the line in number 5. All right, perfect, guys. You should have gotten y equals 3/4 x plus 4. All right, writing linear equations in slope-intercept form. Now, it is already a linear equation. It's actually in standard form. We'll get to that in our next lesson. But first, we need to get it into our lovely y equals mx plus b. So I'm going to go ahead and I'm going to isolate y. So I'm going to subtract the x term from both sides. But my goal is to make it look like the mx plus b. So when I rewrite the next line, I'll have -4y equals -5x plus 16. That way my x term is coming first. Divide both sides by -4. So we end up with y equals, if I go ahead and I divide the first term by -4, negative divided by a negative gives me a positive 5/4 x. And then if I go ahead and divide the second term, so 16 divided by -4 would be -4. And then remember to graph, we graph our y-intercept first, so I go to -4. And then I go up 5, and then over 4. And you keep going until you hit the edge of your graph, and then you'll connect your points. So your graph should look something like that. All right, last example. So you'll notice there's a lot of fractions. Fractions are fun, fabulous, and fantastic, so don't get too overwhelmed. We're going to approach it in the same way. We're going to move our x term over first, so I'm going to add 3/4 x to both sides. So I end up with 1/2 y equals 3/4 x minus 1. You want to multiply by the reciprocal, so I'm going to multiply both sides by 2 over 1, but that's really just the same thing as 2. And we're going to distribute on the right side. On the left side, I just have that y equals, when I distribute this fraction to the fraction, I multiply together the numerators, so 3 times 2 would be 6. Multiply together the denominators, so 4 times 1 would be 4, x. And then times the -1 would be -2. Simplify your fraction. And then you can just plot your graph and you'll be good to go. So your line should look something like that. All right, guys, so at the end of this video, you should feel pretty good about writing equations in slope-intercept form and interpreting graphs and equations in slope-intercept form. All right, until next time.